Look around you. There is distance between you and the walls. There is room to stretch your arms. It feels completely obvious that we exist inside a vast, invisible three-dimensional container, moving forward to the steady ticking of a universal clock. But that container is a biological construct. Deep inside the brain, specialized neurons called place cells and grid cells constantly fire, building an internal coordinate system. Your brain translates raw sensory data into a working simulation of distances and depths to keep you alive. Early physicists mapped this exact biological intuition onto the cosmos. Isaac Newton built his entire system of physics on the assumption of absolute space, a rigid, unchanging theater stage where the universe performs, even if no actors are present. This assumption worked beautifully for over 2 centuries. Newton's equations, utilizing this invisible grid, predicted the arcs of cannonballs, the pull of ocean tides, and the orbits of planets with stunning precision. Because the math worked so well at human scales, we assumed the theater stage was real. But the grid we navigate every day is a neurological and historical mirage. Our intuition about the basic fabric of reality is actively deceiving us. To see where Newton's rigid framework fractures, we have to look at the extreme limits of the cosmos. Albert Einstein proved that space and time are not a fixed container at all. In his theory of general relativity, they form a single, flexible fabric that physically stretches and bends around massive objects like stars and black holes. Yet Einstein's elegant geometry still held on to one crucial assumption: that this flexible fabric of spacetime is completely smooth and infinitely divisible. No matter how close you look, the surface remains continuous. That assumption violently collides with quantum mechanics. In the microscopic world, nature is not smooth. It is restless, jittery, and defined by erratic fluctuations of energy. These two incredibly successful descriptions of reality refuse to coexist. If we zoom past Einstein's cosmic geometry, down to the absolute smallest scales, the smooth fabric of the universe begins to tear itself apart. If we dive past the human scale, down through cellular biology and the atomic nucleus, we are searching for the literal bottom of reality. Moving from a human to an atom, then dropping 20 orders of magnitude smaller, we hit a physical boundary, the Planck length. Here, physics breaks completely. The math produces infinite results, gravity and quantum mechanics clash, and continuous vase dissolves. Physicists call this chaotic threshold quantum foam. Instead of a calm, geometric sheet, space-time at the Planck limit behaves like a wildly turbulent, boiling ocean. You simply cannot divide a physical meter endlessly. Reaching the Planck scale reveals that reality has a microscopic pixel limit, forcing us to rethink what space is actually made of. If there is no smooth spatial fabric at the bottom of the universe, we have to figure out what actually constructs the dimensions we interact with. The answer likely relies on a process called emergence. Think about a single atom. It does not possess a property called temperature, but when millions of atoms move together in a collective pattern, they create the emergent physical sensation of heat. Some physicists apply this exact logic to reality itself. The theory of loop quantum gravity proposes that space is woven from a vast network of tiny, discrete quantum relationships. Just as atoms generate heat, these microscopic connections collectively generate the geometry of space. We see another hint of this in the holographic principle. As this visualization models, the entirety of the three-dimensional space we experience might simply be a projection, emerging from quantum information encoded on a flat two-dimensional boundary. Under these modern frameworks, space and time are absent from the deepest layers of reality. They are large-scale illusions emerging from the behavior of non-spatial data. We are already seeing theoretical physics abandon the space-time grid. When researchers study high-energy particle collisions in massive accelerators, they traditionally map the interactions using complex coordinates of where and when the particles hit. But researchers found they can bypass those complex coordinates entirely. They can predict the exact same collision probabilities by studying the geometry of an abstract mathematical object called the amplitudron, an object that exists completely outside of space and time. This points back to a fierce historical debate. Centuries ago, Newton's great rival, Gottfried Leibniz, argued that an absolute spatial container was a fiction. He believed space was nothing more than the relationships between objects, and that without those objects, space simply would not exist. The deepest equations in quantum gravity are now suggesting Leibniz was right. Space is not a stage waiting to be filled. It is the network of relationships itself. Space and time are the shadows cast by deeper mathematical structures. We are not sitting inside a vast empty container. We are actively woven out of the relationships that make up the universe.